All right, in this lesson, we're going to look at how to solve for time, the time variable in these exponential functions, okay? So how long will it be until something happens? So here we have a population of 30,000 is growing by 15% annually. That's 0.15. That's a rate of 0.15. 15 divided by 100 is 0.15. How long until the population reaches 40,000, okay? So we're going to have our ending value, okay? Let's just set up the original, okay? So P of t is going to be equal to the starting value, 30,000, times 1 plus 0.15, which is 1.15, okay? So we'll write that 1.15 to the power of t. So this is our function, okay? This is our population function. We plug in an amount of time, and we get an ending value, okay? Well, this is saying that the ending value is going to be 40,000. So we've got 40,000, plugging that in, but we don't know the time. We're solving for time. Is equal to 30,000 times 1.15 to the power of t, okay? So all this is an exponential equation where we're solving for a variable in an exponent. So we've done this before. This is not in the correct form. We have an extra number here. So we're going to start off by dividing by 30,000. That's going to cancel this. So we have to divide over here by 30,000. Okay. Now, 40,000 divided by 30,000 really is just 4/3. Okay, but we'll leave it as 40,000 over 30,000 in case it's easier for you. So now all we have left over here is 1.15. So we have 1.15 to the power of t is equal to 40,000 over 30,000. Okay. All right. And now we got to cancel the base, so we're going to do a logarithm. We're going to do log base 1.15 of 1.15, to the t power, okay, is equal to log base 1.15 of, 40,000 over 30,000. Okay. Now over here, we're going to cancel the 1.15. We're going to have t is equal to log base 1.15 of 40,000 over 30,000. Okay? Which, by the way, you can just do as 4, like I said before, you can just do it as 4 over 3 because all these zeros cancel each other out. Okay? But if you don't like that I'm doing that, if that confuses you, we'll leave it. Okay, but you could do it just as 4 over 3. So now we can convert this into the change of base so we can put it in a calculator. This is going to be the natural log of 40,000 over 30,000. That's an ugly 3 right there. Okay, divided by the natural log of 1.15. So we'll go ahead and put that in our calculator. Okay. So we'll do the natural log of 40,000 divided by 30,000. Now we'll come out of the log, close off the parenthesis, then divide by another natural log, the natural log of 1.15. We press enter and we get 2.058, and we're going to leave it as a decimal, okay? So time is 2.058. 2.058 what? Years, okay? And so it's going to take 2.058 years in order for population 30,000 to grow to 40,000. All right, now let's try this second one here. It says a population of 2,000 is shrinking continuously. Okay, it's shrinking, so it's decay, and it's continuously, so it's going to have an E by 6%. And 6% means 0.06. That means a rate of 0.06. And it's going to be negative because it's shrinking, okay? Per minute. How long until only 300 of them remain, okay? So our ending value is going to be 300 is equal to, our starting value is 2,000, okay? And it's continuous, so we're doing E. It's shrinking, so the rate is going to be negative 0.06. And now we're solving for time, t. We want to know how much time until 2000 becomes 300 at a shrinking rate or a decay rate of 6% or negative 0.06, okay? So we're going to start off by dividing by 2000. That's pretty much how we're going to start all of these, because what we have to do is we have to divide the ending value by the starting value to get the exponent by itself, okay? And again, we can cross off some zeros here if we want to. We can make it 3 over 20 if we want to. In fact, I'm going to do exactly that this time. I'm now going to do it as 3 over 20 because I canceled some zeros. So now I have e to the power of negative 0.06 t is equal to 3 over 20, okay? Now to cancel the e, I'm going to do a natural log. Well, let's do a new line. Natural log of e to the power of negative 0.06 t is equal to the natural log of 3 over 20, okay? And now the natural log and the e are going to cancel. And all we're going to have now is negative 0.06 t is equal to the natural log of 3 over 20. Okay? Now we can just divide by negative 0.06, and that's going to cancel on the left, and we divide by negative 0.06 on the right. And now this is going to cancel, and now we're just going to have t is equal to, so t is equal to, and this is in minutes. Look, this is 6% per minute, so this is in minutes. T is equal to the natural log of 3 over 20 divided by negative 0.06, which we can do in the calculator, okay? So we're going to do the natural log of 3 over 20. We're going to close the parenthesis, then divide that by negative 0.06, and we get 31.619. This 6 is going to make this 8 and 9, so it's 31.619 minutes. All right, so it'll be, what do we say? 31. 31.619 minutes, okay? Let's try another one. All right, here we have $8,000 is deposited in an account that returns 7.8%. Returns means it's growth. Returns means growth, okay? So here, the 7.8%, that means that R is 0.078, and it's positive, it's plus, okay, per year. Oh, this is compounded continuously, so it's going to be an E. How long until there's $50,000, okay? All right, so we're going to, the starting value, or the ending value is 50,000, okay, equals, starting value is 8,000, and so we'll put 8,000, and it's compounded continuously, so it's E. The rate is 0.078, so that's positive 0.078 to the t power, okay? And this is in years, this is in years. So we're solving for a number of years. Start off by dividing by 8,000 on both sides, divide by 8,000, okay? We'll cancel some of the zeros, and we'll have 50 over 8. So we're going to have E to the power of 0.078 t is equal to 50 over 8. Now we're going to do a natural log of both sides. Natural log of e to the power of 0.078 t is equal to the natural log, that's a t right here, sorry, it's ugly, 50 over 8, okay? Over here, we're going to cancel the natural log and the e, so all we have left is 0.078 t. So we have 0.078 t is equal to the natural log of 50 over 8. Okay. Now we're going to divide by 0.078. This looks just like the last one because it's an e. Divided by 0.078. We're going to cancel the 0.078, and all we have left is t equals this thing. Okay. So t, the time, is equal to the natural log of 50 over 8 divided by 0.078, which we're going to go key into the calculator. So we're going to do the natural log of 50 over 8, close the parenthesis, divided by what? 0.078. Divided by 0.078 and we get 23.495. The 6 is going to make this 4 a 5. 23.495 years. So 23.495 years. It's like 23 and a half years, okay? For $8,000 to become $50,000, okay? All right, last one we're going to do here is a car is worth $30,000, but it's losing value. It's losing value, so it's a decay at 4.5%. So the rate is 0.045, but because it's a decay, it's going to be subtracted, okay, per year. How long until it's worth only $4,000? So the ending value is going to be 4,000 equals, the starting value was 30,000, okay? Now this does not say continuously, so we're going to do 1. We would do 1 plus, but it's losing value, so we're going to do 1 minus 0.045, okay? Now what is 1 minus 0.045? Well, let's go to the calculator and find out, okay? 1 minus 0.045 is 0.955. So we're actually gonna remove this and put in 0.955. Okay, 0.955 to the power of t. Okay, so we're solving for t. All right, so the first thing we're going to do is divide by 30,000 on both sides, just like we did in the last ones. 30,000. We're going to cancel a 0 here, cancel a 0 here, cancel a 0 here. So we're doing 4 over 30. We want to know how long we get to 4/30ths of the value, which is actually 2/15ths, but we'll leave it as 4 over 30. All right, so this is going to become 0.955 to the t power is equal to 4 over 30. Okay. All right, so we're going to apply a logarithm here. We're going to do log base 0.955 of 0.955 to the t power is equal to log base 0.955 of 4 over 30. Okay. And over here on the left, we're going to cancel the log and the 0.955, and we're just going to have t is equal to log base 0.955 of 4 over 30. This, to key this into a calculator, we're going to have to do a change of base. We're going to do the natural log of 4 over 30 divided by the natural log of 0.955. When we key this into the calculator, let's go ahead and do that. Natural log of 4 over 30, close parenthesis, divided by, whoops, hang on, I messed that up. Oh, I don't want a parenthesis there. I want to come over here. There we go, parenthesis. Then divided by the natural log of 0.955. And we get 43.76. This is a 0, and the 4 will not turn this into a 1. So we're going to stop at 43.76. 43.76 years. Okay, so it'll take 43 years for the value of the $30,000 car to get down to $4,000.